welcome back everyone. In the last video, we started the packager class. If you've not seen that video, you can check that out right here. Because in this video, we're going to be continuing directly with that. And we're going to start right away with the ability to add and load tile maps and game objects in Lua. Now, usually I type everything out. However, there's a lot that has to be done in order to save them. So I'm actually just going to copy them over and go over them. Okay, so we already had these JSON ones and we want to do the same things for Lua. So I'm going to grab these from over here and we're going to paste them in. So all we're doing here is basically the same thing. So we're doing our save tile map, load tile map, save game object, and load game object. But now instead of JSON, we're going to be doing that with Lua. Now, if you remember with JSON, we also added the serialize functions. So we can serialize the components. So we're going to have to do the same thing for Lua. Let's go here and we'll just create these four. And we can go into our CPP file. And I will go down to these functions down here. So we have our four functions here. And we're going to have to, I'm just going to grab them from the other side. I'll do them one at a time. Let's start with the save tile map. Where are they? There they are. Right here. So the save tile map to Lua. And we'll just grab, I'm just going to grab this from the side here and I'll paste it in. And we'll just go over this. So all we're doing here is basically the same thing that we did for the JSON serializer. However, we're using the Lua serializer. And we're just going to loop through all the tiles and then serialize each component. Now we're going to have to go and add these in, and we'll do that right now. But first, let's go to the top and include the Lua serializer. So up here, we have our JSON serializer. We can include our Lua serializer. And we can go back down here. So we have our serialized component function. Right now, if we go to this here, so if we go to core, ECS, components, and then we have our component serializer here. We didn't add anything for Lua yet, but we have to do all of these same functions. You're going to have your deserialize and you're going to have your serialize. This one takes in the JSON serializer, and then this one takes in a rapid JSON value or table. We're going to want to do the same thing for Lua. So I'll just grab those and paste these in. So we have that, and we can go to our PP, go to the bottom right here, and I'm just going to paste that in. But we have our UI type that doesn't exist yet. So this is actually a function inside of the UI component that we haven't created yet, but we can just delete this for now. We don't need. So I'm not too worried about the UI stuff right now. We got a lot of stuff to handle. So let's actually check that out. Let's go to our UI component. Yeah, so that function doesn't exist yet, but we'll go over that in a separate video. Okay. So we go back here and we have our component serializing here. So yeah, the same thing for the UI. And this doesn't know what the Lua serializer is, so we need to include that. So we might as well include that now. We have the JSON serializer, change that to the Lua. Let's go back down here. So yeah, see before, we need to add more stuff here for the UI that I've already done in my other project. However, I haven't done it in the videos yet, so we'll have to go over that. Then we have one more here, this here. So we can actually just get rid of it now, and we'll add all that stuff back in. So that will allow us to actually serialize and deserialize the components to a Lua table now. Okay, so let's go check that out. Back to our tile map loader. Oh, we had an error here. That's not going to work until we go back here. So we already have our JSON serializer here. So we're forward declaring that. We also have to forward declare our Lua serializer. Lua serializer and serialized component should handle that. Right. Now, I could type all this out, but that would just take forever. And there's a lot of stuff I still want to add to the engine that I'm going to have to start a way to make these videos faster in order to get them out, because typing it all out takes a long time. Okay, so we have this here. That should be good now. So it doesn't know what soul is, so that's one issue. That's not the issue. We're going to have to include soul. So include soul, soul.hpp. Let's actually just try to build this, make sure it's all working. All right, so that worked fine. Perfect. So let's quickly go over these functions here. So all I'm doing is, if we go up to the top, is all I'm doing is creating a new table for the transform, and we're just serializing everything here. We're just adding new key value pairs. So the position would be another table with two values, the X, Y, then you're ending your table. This would be your position, then your scale, rotation. That's all we're doing. And so we go through every single component and serialize it. Basically the same way that we did it for JSON. And then the deserialize, you go the opposite way. So if we go down here for deserialize, so what I'm doing is I'm passing in a transform and I'm reading in from the table the values and setting it in that particular component. Okay, so that's our deserialize. Now, all of this will be pushed right away, so you can just go to the GitHub repo and take a look at this if we went too fast here. But typing this all out would take a long time, so just go grab it from the repo. Okay, so let's go back to the tilemap loader and we'll quickly go over this here. So all we're doing is we're getting our Lewis serializer, getting the file, and then checking to see if it exists, make sure it exists, then do your error. Then we're starting a new table. So this will start the table for the tile map, and then it will loop through all the tiles. So it grabs every from the registry that's passed in, and it's going to get the registry, grab the view of all tile components. So every entity that has a tile component, and then it's going to loop through these, create the proper tables. So we have our tile, and this is just so we can call the get component function. It's just a wrapper, really. And then we have a registry, we have our tile, and then we're just serializing the components. So this will take in the Lewis serializer, and it'll take in the transform and it'll write it to that table. Okay. Same thing with the sprites and same thing with all these other components that we had to do. Then you finish it up. You end your tables, you end your array, then you end your scene, and then there you go. Okay, so we can actually do the same thing for load. So let me grab that right now. And we can take this and paste that in. Now with loading, it's different. You're using the soul state. Now we don't need the main soul state for this because we just need to read the file. So it's going to take in the file and it's going to safe script that file so we have it. Then we can loop through the tile map and load everything in. Okay, so it's just doing checking for the components, and we will have call these maybe tiles. Those might be a tile map. So you have a key value pair, and then you're just loading all of the components for that particular tile. Okay, so each entity here is a new tile. It doesn't need a name, it doesn't need a group, but we need to put these in here, and we will just deserialize them if it is a table. Okay, so if those tables exist, we deserialize those components. Okay, and then at the end, we add in a new tile component. All right, cool. Now for the save object and load object is basically the same thing. However, instead of tiles, it's now game objects. Okay. So we'll grab that. But we're basically doing the same thing. So the save game object, we just paste that in. Now, I'm not sure why this does this lately. It wasn't doing this before on a different version of ENTT, but now I'm getting all these errors here. But it's an error, but it still compiles. So I'm not sure how to fix that. As long as it's compiling, it's working for me. So I'll look into that one day. But let's just take a look at this. So all we're doing here is we're doing our same stuff with our Lua serializer. We take in the map file, make sure it exists because we want to write to this file. And then all we're doing is we're going through all the game objects. So it can't have a tile component and it can't have an uneditable component. Now, the uneditable component, that is for like your player start and other things that we don't want. That's part of the registry, but we don't want it to actually be saved. Okay. And then all it does is it creates a new table for those game objects and writes their component and everything. Now, this one does have relationships. Now, the relationships are a bit complicated, but it is somewhat working, but there's still some work to do with those. And then all it does is end your table and finish your stream. So it just basically writes all of your game objects for that particular scene. That's what it's going to do for this particular scene, for this registry. And each registry is part of a scene, so you're saving each scene. Okay. And lastly, we need to do the load of the game objects. And I could just bring that over as well. This one's a little bit bigger and paste that in. Now, the reason why this one's bigger is because we're dealing with relationships, because game objects can have relationships, tiles can't. So where is that? Sorry, it went too far. Right here. So it's the same idea. So we have our Lua state, so we can load the Lua script, and we're rolling through it, and we're making sure this is just a map of entity to relationships because each one has to have a tag. Now you can't save the ID. The reason why you can't save the ID is because ID could be different. All right. Each time that you run ENTT, it could have a separate ID. So you can't just use that ID as a way to save the relationship. Okay. So we're looping through this here, and we have our transform, and we have this here, and we're just deserializing everything that you need. So if it has the sprite, it will deserialize the sprite. If it has a box collider, it will deserialize the box collider, and so on. And then it gets into the relationships, and it does the same thing. So it'll grab all of these particular tags, or whatever the name that you gave for these siblings. We don't care about the ID, we care about the tag for it. Okay. So each sibling will have its own tag, and then we'll put it in the map so we can actually build it later. So right here we have this lambda. This is just to find the tag. If it doesn't have the tag, if you can't find the tag, it will return a null entity. Otherwise, it will return the entity that is there. Okay. Then this is just looping through all of the save relationships. That's all this is, a structured binding, and it loops through those, checks everything, and then looks for the tag and sets it accordingly. Okay. All right. Now, lastly, we have this part here and we need to change it. So if use JSON, we'll use JSON. So we can just do this here. Instead of just doing return false here, we can get rid of that. Then we can go use a ternary operator here. Say if use JSON, or go save tilemap Lua registry s tilemap. Wow. And we're going to want to do the same thing for all of these. Load tilemap Lua. Actually, we can just copy this. All right. And one more for the save the object. Okay. So that was a lot there. So basically what we're doing is if we're using JSON, we want to save it to JSON. Otherwise, we want to save it to Lua. And it'll go through all of this save stuff that we added. Whew, lots of stuff there. Make sure you check out the GitHub repo to actually go over this in more depth, but it should make sense. If you made it to this video, you should be able to just grab it and move on from there. So now we can actually go back to the packager and continue with the packager. Okay, let's go there now. Actually, hold on. Can't go to the packager because I still need a way to export these scenes to Lua because we're not saving these scenes. Each scene is only saved to the registry when it's loaded. So we need to have a function that will actually load the scene to a separate registry so we can save it. Okay. So that's what we're going to do now. So let's go to the scene object of the editor, not the main scene here. Let's go here to the editor, here, editor, scene, and then we'll go to scene object. Okay. Then right under unload scene, load scene, right here, let's create another function. And I'll say std pair. The reason why I want to use a pair is how I want those two files. Std string, std string. Two strings, that's just going to be two file names. It's going to be for the game object path and the tilemap path. Okay. So when I go export scene to Lua, it's going to take in the const std string reference scene name const std string reference. We'll just say export path. That's going to be most likely the temp data path However, you may want to export it somewhere else. So we'll just have this function available. And it's also going to take in the registry. So that's going to be scion for ECS registry reference registry. Now, this is going to be a separate registry that is created just so we can load the scene. Okay, let's do that now. Cool. All right. So the first thing we need to do is actually check to see if the scene data path exists. Let's do that now. Let's say get the scene data and load the scene into separate registry. Cool. So I want to go if not fs exists of the ms scene data path. We should have an error here. Fail to export scene. Scene data does not exist. And we can just return empty pair. And if it does exist, we need to read this in. Now, the scene data is actually a JSON file. We need to read in that JSON file so we can parse it. I'm going to go std if stream scene data file. Scene data file. Open. Scene data path. I can go if not scene data file dot is open. Well, then we have another error. Scion error. Fail to open scene data. I return an empty pair. All right. Now the scene data file could be empty if it's just created. If so, we just want to leave. There's no need to do anything. Okay. So if scene data file dot peak equal to std if stream trades type and a file, then just return. Otherwise, now we need to read everything or read the buffer into a string stream so we can parse it with JSON or our rapid JSON. So std string stream Awesome. Then we need a rapid JSON document. Rapid JSON document. Then we just check for some errors. So if it has a parse error or not, doc.isObject. Fail to export scene data file is not valid JSON. All right. Same thing. And all we're doing is getting the parse error and making sure that we can tell the user, let the user know that we have an issue with this file. All right. We want to assert that the document has a scene data member. So we can just use assert for that. Scion assert doc dot as member scene data scene data member there. And we can throw an error here as well. So now we actually want to get the project info so we can get the scenes path. So I want to go auto reference the project info to main registry dot get context project info pointer. So for that, we're going to need to include the project info. That's in our, oh, it's already there. So we need to include core by itself. That's why it doesn't see. So down here, our stuff down here, project info pointer. Cool. Now that should exist. I shouldn't have to test for that, but I'm going to put it in there anyway. I'm going to go auto opt scenes path because we can get the path as an optional. That's equal to p project info try get folder path. That's e project folder type scenes. Now this should exist. Should be set up when the project is loaded or created. Scion cert opt scenes path scenes folder must exist. So now I need to check to see if the tile map is empty. If it's empty, I want to load it from the scene data. Okay, so we need to actually create the scene data right here. Might as well do that first. Let's go const rapid JSON value reference scene data equal to doc at data. So now that we have our scene data, first I want to do is this. We go if ms tile map path is empty. We need to get that path from the scene data. That's equal to fs path opt scenes path scene data at tile map path dot get string dot string. All right, does that make sense? So we're creating a new path, and inside of that path, we're concatenating these two here. So we're concatenating the scenes path with the tile map path that we're getting from the JSON data. Okay, all right. We want to do the same thing for the object path. So grab this here, paste it down, change this to S object path, object path, copy that. Object path, scene data, change this here to object map path. Cool. So then we need to load the canvas. So if scene data dot has member canvas and canvas dot width. Oh, before we do that, we want to go const rapid JSON value. Actually, we can copy this up here. Rapid JSON value, copy that, paste that in. Scroll this down a little bit, change this from scene data to my canvas, and change this to scene data canvas. Cool. Then I can go m canvas dot width equal to canvas at width dot get int. Then we got height, tile width, tile height. Change these. Awesome. Then we're going to want to check the map type. So I want to go if scene data dot as member map type. Because we can do grid or ISO maps, the ISO maps are still not fully supported, but they're there. A string s map type equal to scene data at map type dot get string. Then we can go if map type or s map type equal to grid. Then I want to say me map type equal to scion or e map type grid. Then I want to say copy this else if ISO map type is ISO. Awesome. All right. So now we want to try to load the tile map and object maps. Okay. So we want to go auto the tile map loader equal to std make unique tile map loader. Then I can say if not the tile map loader load tile map. And now we want to go registry ms tile map path. And then yes for JSON because we're loading it from the editor. Okay. But if it can't load it, we want to go scion error failed to load tile map. MS tile map path. Then we'll try to load the game objects as well. So let's copy this. Load game objects. MS object path. Failed to load game object map. Awesome. Otherwise, that means we have loaded successfully into our. Actually, we should fail early here. Well, we'll return. So if none of those get loaded, then we should return false or return fail to return. Okay. Otherwise, now we want to actually try to export the path. Okay. So we can go fs path export path of s export path. If it does not exist, well, we also want to have an error here. So scion error failed to export scene to Lua export path does not exist. S scene name s export path and then return. All right. Whew, lots of stuff going on here. So let's go to fs path. Now we want to make our tile map path. Tile map Lua And we'll start that as export path. And we'll say tilemap Lua or equals scene name scene name plus tilemap.lua. Then I want to go if not the tilemap loader, save tilemap, takes in the registry, tilemap, tilemap Lua dot string, and false now because this we don't want to save it to JSON, we want to save it to Lua. Then we want to have an error here. Scion error failed to save to export scene. Okay. Oh, it should have a if this fails, there should be an error already in there. And we can return here. And we want to do the same thing for the object map. So we can copy all of this here, paste, change this to object map. We'll just say object Lua. All right. So objects being saved, saving game objects. Perfect. Otherwise, we fail. Then if we make it here, awesome. So we just want to make a pair of the two files, the new files. So we want to go std make pair tilemap Lua.string and the object Lua.string. Now these should be the paths to those files, and we can use these files in our exporting. We're going to export the scene to Lua, and it's going to create those files for us, and then we're going to get those file paths right here. And we're going to take those file paths, pass it back, and we're going to use those when we're compiling to LUAC. Okay? All right. So that's it for that. Now we can actually go back to the packager here and do the create scene files. I know that was a lot, but we had to do it eventually. Now I could have done this all in the background and just asked you guys to go see it, but I wanted to try to go through it a little bit beforehand so you guys can kind of see the process that I was going through. Okay, so let's actually try to build this really fast. Awesome. So that's working. So now we can actually do this function right here. So now we can actually create the scene file. So let's actually just copy this here, cut this out here, paste that in, and we're going to say scene files. And we're taking in the scenes value here, the rapid JSON scenes value. So I want to go if not scenes dot is array. And we're going to want to have an error here. I want to go scion error failed to create scene files. Scenes was not a valid JSON, right? And we can just return the scene files. Then we're going to want to get the content path. So we can go auto opt content path. That's going to be equal to our package data, mp package data, project info, try get folder path of the project folder type content. We should assert this to make sure it's there. If we're running in debug, that is. Opt content path. Content path wasn't set in the project info. Otherwise, we can check here. If not, opt content path, say Scion error, failed to create STLUA files, and path not set project. Turn the scene files. So now what we want to do is loop through the scenes array and grab all that data from the scenes, okay? Or for the scenes. For const auto reference JSON scene in our scenes get array. So we're looping through all of our scenes. We want to get the scene name, the data path. We want to go std string scene name JSON scene name dot get string. And then we also need the scene data. So we'll say scene data here. This is the scene data path. And we can actually create a file system path for scene data path. That's going to be equal to our opt content path. Because we want to get the folder that's in our content that's holding on to our scenes that has all of our files in there. Okay. Then we need to create a registry here. This is the registry that we're going to be using for loading the scene to Lua. So Scion for ECS registry, your registry. Then we're going to go auto the scene object equal to std make unique scene object s scene name data path dot. And then we need to export the scene to Lua, and that will return the tile map and the object map paths. So we can say auto, and it returns it as a pair, so we can use a structured binding here. So tile map s object map equal to p scene object export scene to Lua. That takes in our scene name, and that takes in the temp path because that's where we want to put it. MP package data s temp data path s temp data path, and then the registry. Cool. Once they are exported to Lua, we now need to just ensure that they exist before we go any further. So we're going to go if not fs exists fs path s tile map or not fs exists fs path s object map. Then we're going to have an error here. Scion error fail to create scene files for scene name. Here I'm just returning an empty vector, so I'm not returning any scene. So if one doesn't work, none should work. That's how I want to do it. Now we don't have to do it that way, but we can. Otherwise, I want to go scene files dot pushback s tile map. And then we can do the same thing for the object map. S object map. And then lastly, we can go scene files. All right. So that was a lot of stuff to cover. So what we ended up doing is we added all the serialization and deserialization of our game objects and tiles to Lua, or components to Lua, sorry. We added that to our tile map loader so we can handle those, the tiles and the game objects. And we also added in the ability to export the scene directly to Lua from the scene object. Cool. We now go through all the scenes and then add them into our scene files, or we export them to Lua, add them into our scene files so we have them all as Lua files, and then we can send them out. Now we do this so we can compile them all to LUAC during the packaging process. Okay, so that's it for this video. And in the next video, we're going to go over the copying files to the destination and the copying the assets to the destination. And we're also going to test out the packager. Now, we're still missing the runtime executable, and we'll do that in the video after the next one. We'll get into the runtime executable, and then we'll actually be able to package the game. Okay, so that's it for this video. Please like and subscribe if you haven't done so already. Also, leave a comment, and please leave comments or questions below. If you have any issues, let me know. We also have a Discord channel. You can go onto that if you don't feel like leaving a comment. You can go on the Discord. There's more space to put pictures or whatever you need to explain any issues that you have further, or just ask any questions, programming related or whatever I can help out with, and also with the community. All right, so that's it. Take it easy.